and welcome. In today's lesson, we're going to dive into the world of exponents. Now, you might have seen numbers like 2 squared or 3 cubed and wondered what those little numbers actually mean. Well, by the end of this lesson, you'll not only know exactly what exponents are, but also how to use them to simplify math problems more easily. Let's begin with the basics. At its core, an exponent is a shorthand way of writing repeated multiplication. Let's take a look at this first example, 2 squared. What does 2 squared mean? The base number here is 2, and the exponent is 2. The exponent tells us how many times the base number, in this case 2, is multiplied by itself. So 2 squared means 2 times 2. That's it. We multiply 2 by itself, and the answer is 4. So the first thing to remember is that exponents represent repeated multiplication. It's just a quicker way to write out something that would otherwise take a little longer. Let's look at another example to make sure you've got it. Here's another example, 3 cubed. What does 3 cubed mean? It means 3 times 3 times 3. So we multiply 3 by itself 3 times. This equals 3 times 3 equals 9, and then 9 times 3 equals 27. So 3 cubed equals 27. Now you're probably wondering, what if the exponent is a 1 or even a 0? Great question. Let's take a look at both of those cases. If we have something like, this is saying 2 raised to the power of 1. It's important to know that any number raised to the power of 1 is just the number itself. So 2 to the power of 1 equals 2. It's the same thing as just writing the number 2. Now let's look at 2 raised to the power of 0. This one might seem tricky, but here's the simple rule. Any number raised to the power of 0 equals 1. So 2 raised to the power of 0 equals 1. It's always 1. No matter what the base number is, unless the base is 0, but we'll get to that another time. Great! So far, we've learned that exponents are just a shortcut for repeated multiplication, and we've seen that when the exponent is 1, the number stays the same, and when the exponent is 0, the result is always 1. Now let's take a look at how to read exponents in different formats. We know that 2 squared means 2 times 2, but how can we write exponents in different ways? You may have seen something like 2 squared equals 2 times 2 written in expanded form. This just breaks down the multiplication part of the exponent for you, so you can see what's really going on behind the scenes. But we don't always need to write the exponent as multiplication. We can also use exponential notation where the base and exponent are written together, like this, 2 squared. This is the shorthand version we use in math because it's quicker and easier. Here are a couple of examples for you to try. 4 cubed means 4 multiplied by itself 3 times. So it's 4 times 4 times 4. 5 squared means 5 multiplied by itself twice, so 5 times 5. By now you should have a solid grasp on what exponents are and how they work. You've learned how to read exponents, understand their meaning, and simplify basic problems. Before we wrap up, let's do one last example together. Let's take a look at 3 to the power 4. What does this mean? We can break it down into 3 times 3 times 3 times 3. And when we multiply, 3 times 3 equals 9, and then 9 times 3 equals 27, and 27 times 3 equals 81. So 3 to the power of 4 equals 81. There you have it. We've covered how exponents represent repeated multiplication, how to read and write them, and how to handle special cases like exponents of 1 and 0. In the next lesson, we'll dive deeper into the laws of exponents, how to simplify and combine them when we start multiplying and dividing with exponents. But for now, make sure to practice these basics, and you'll be ready to tackle more complex exponent problems in no time. Thanks for watching, and I'll see you on the next lesson.